What's up, you data friends? It's Yanis here and welcome to my channel. Now please note that this video is actually video part 2 of the time series models series of videos that I will be running. In the first video, we went through what is time series models and how they work, the machine learning process, the libraries we're going to use for this tutorial, the problem formulation phase, how to load data from Excel into Python, how to do the pre-processing phase. Then we have covered how to split the raw data, and then we've shown how to run Arima models, which is Autoregressive integrated moving average, how to evaluate it and how to improve it, so how to do parameter tuning, and we have also shown how to run Auto-Arima. In this video, we're going to show how to run Prophet time series model, then how to run multiple models together. So in this example, we are running Arima and Auto-Arima. Then I'm going to show you how to run 4 models in one go. So Arima, Auto-Arima, Prophet, and Regression, which is this example we have over here. Then I'm going to show you how to save the results in data frames. So as you can see, the code keeps getting bigger and bigger. Then I'm going to show you how to test it on multiple countries. So those 4 models running on more than one country. So in this example, we have 1, 2, 3 countries. And at the end, I'm going to show you how to run it on all countries together, which is going to be the output we have over here. So 4 different models in a lot of different countries. And at the end, I'm going to show you how to combine the actuals with the predictions and how to export the data in a CSV file. In the next video, we're going to be showing how to take your output and create this Power BI dashboard from scratch that has all data for all countries, the validation phase and the predictions, the mean square error of each model, and some additional visuals down here. Right, before we start this tutorial, let me just say that if you're new to my channel and you're passionate about data science, then please consider liking this video, subscribing to my channel, and enabling notifications for my future videos. Right, starting from where we left it last time, some notes before we actually ran Prophet. Prophet was developed by Facebook's core data science team. It's a procedure for forecasting time series data based on an additive model where non-linear trends are fitted with some sort of seasonality. It works best in time series that have strong seasonal effects. This doesn't apply in our case because we use GDP per capita trends, and also it handles missing data and outliers well. If you want to learn more about how Prophet works and the maths behind it, then click on this link here. Right, in order to run it now, we need to follow these steps. First, we create a copy of the dataset we were using in the previous video, which is the Australian dataset. So if I just show you very quickly, copy, paste, dot, head, this is the dataset, country, time, and value. Then I'm just selecting time and value. So this is time and this is value. Afterwards, we have to rename our columns into DS and Y. This is because the Prophet model down here is not accepting any other column names. So you actually have to rename your columns into DS and Y. And the last thing we have to do is that we have to convert DS to datetime. It only accepts type datetime in the model. So AU3 is going to look like this. If I run it quickly, let's do the head. So it's exactly the same data set as before, but with just different column names. Then we we define the model, and then we fit the model with this data set over here. The next thing we have to do is to define the period for which we want to make a prediction. So it's exactly the same period as before, which is this index we've created in the previous video. So it's from 2011 and onwards, all the way to 2017. However, it has to be in a data frame, and this is not a data frame. So what I do is that I pass it into a PD data frame back to this df_index of 7 years. Then I rename the column into DS, as we said before, and then I convert the DS column into datetime. Then I make my prediction, so model.predict, and then I pass this data frame into here, and this is actually going to give me a data frame back. So if I run this quickly, you can see that the return is actually a data frame. And the prediction out of all this data frame is the y hat down here at the end. So what I have to do is that I have to create a series with that y hat, the values, and then pass the same index as before, and then rename this series into profit. Then we have exactly the same code as before, but instead of forecast 2, now we have forecast 3, and we are plotting the data down here. Additionally, we are printing the root mean square error, but it's actually the mean square error because we are not squaring it, which is $1,188. So as you can see, if I run it again, the profit make a much better prediction that Auto-Arima or Arima we have at the top, because this is 3,000 and this is 1,800, and if we check profit is 1,100. So it did a very good job. Right, the next thing we're gonna do now is to run multiple models, time series models together, and we're gonna start by running Arima and Auto-Arima together. Also, we're gonna set it in a structure where it can loop through a lot of different countries, but we're gonna stick with Australia for now. Later on, we're gonna release all the countries. So the first thing I do here, let me just show you quickly that these countries has all, if I run it, it has all the distinct countries we have, as you can see. And what this loop is gonna do, this for C into countries, is going to start with the first country that we have in countries and run all this code below, which we are going to explain. However, I also have this code down here, so I can easily comment this out. So this is all countries, and this is just Australia for now. Right, so the first thing we do is that we say for C in countries, then this country is actually Australia. So C is going to be Australia, the first choice. We want to filter the training data we want. So we start by filtering the training data, and just by taking all data set where the country equals C. And remember, C is Australia, and this is going to have 3 columns. And then I take this data set, which is the same as this one, and then I limit it into these 2 columns. And these are the columns we are going to feed in the data model. I repeat the same thing for my validation data. So again, 3 columns, 2 columns, and then I repeat the same thing for all data. So the reason we have all data here, we haven't shown this before, is because after we finish, if you look at the graph, after we finish with the validation phase, which is somewhere around here, we want to use all data, so all blue, same with this blue, because this is still actual data, in order to forecast the data after 2017. The next thing we have is that we have to convert the date column into datetime. So we do this for both our training, our valid, our all data, and we also rename the valid data, the validation data, into valid data. This is because down here we want to see the blue. You can see the blue as valid data. Right, moving on, the next thing we do is that we create the index going forward. So this is the index from 2011 all the way to 2017. We have shown this in the previous video. And another thing we do, which we haven't done before, is setting the future index. So the future index is going to be from 2017 and onwards, which we are going to use for all data. So if I run this, you can see it's 2017 and onwards. The next thing we do is that we are dropping all tables. So the reason I drop here training forecast 1 and training forecast 2 is because, let's say Australia runs fine on these Arima models. So I have 2 Arima models here. So it's trying, and then both of them work. And then in the next loop, we have Cyprus, and then Cyprus try to run these models, but it fails. Then it's going to move into print. So T forecast 1, the training forecast 1 for Australia is not going to get deleted, and it's going to get passed into Cyprus. So before we even start with the forecast, I am resetting all the forecasts just to make sure that the wrong values are not going to get passed in different countries. So this is going to do something like try, drop all these tables if they exist. If not, and this fails, then it's going to print nothing. Same thing happens with the data frames, which we're going to create further down the code. So we still haven't created those, but each time a new loop comes in, we are just setting them to 0, or we're just deleting them. Right. So the first thing we do now is that we try to run these two things. And then if they fail, it's going to print this Arima train error. So I try my first Arima model. So this is exactly the same code as the one we've shown in the video part 1, but I'm just going to use the two best parameters for this manual Arima. So the first parameter we have is 0, 2, and 3. So if we scroll up into our code for the first Arima we had, which is, where is it? This one over here, 0, 2, and 3. And then the second best parameter. So if this one fails for the next country, then I'm going to use the next best parameter, which is this one over here. So 0, 2, 2. So if I scroll down, I try on 0, 2, 3, and then I want to try on 0, 2, 2. So what this is going to do is going to try, and then it's going to come down to this try. It's going to try to run this. So run the Arima, fit the Arima, make the forecast of the next 7 years, and then into this training forecast, pass the same index of the next 7 years, and then rename it into Arima. If this combination fails now, it's going to move down to this one, and it's going to try to do exactly the same thing with a different combination. If this combination fails too, then it's simply not going to run Arima model. It's going to print Arima train error. And this is actually for the validation phase. So this is for running this. Let me show you. This is for running the Arima. So this red line, this is the validation phase. And we need another Arima for the future phase, which is this one with the triangles. So if we go up, we copy this, all of this code, exactly this code, we paste it down here, and this is for the future phase. And instead of using the train data, we're going to use old data. So as you can see here, we've used train data, same with this one, train data, but this one we're going to use old data and save it into the future forecast one. So the first one is the training, the second one is the forecast. And if this fails, it's going to throw an Arima future error. Actually, by going back and watching my video, I've realized that this is not the second, sorry, this one is not the second best value. There's actually another second best, which is the 324, 322, 324. So it's 410. So I'm going to set it back into 410. This one is 410. So the reason I have this manual Arima, by the way, is because in some cases, you're going to have domain knowledge and you're going to know exactly which order you want to try as manual before you run the Auto-Arima. So it's always good to have a manual one and then the Auto-Arima one that we're going to show right now. Right. So the same process as above here, we need one for the validation phase and one for the future phase. So we start by training our Auto-Arima. We set seasonality to false and m equals 7. So again, this is exactly the same code as the one we have shown in the previous video. But on the first one, we are using the training data. And then on the second one, we are using all data. Then on the first one, the indexes, again, we need to pass the index for 7 years. And then on the second one, we need to pass the future index. So just to show you which line is this one. So this line is Auto-Arima valid. So Auto-Arima, which is this green down here, so the validation one. And then the future Auto-Arima is from 2017 and after, which is our prediction for the future. So this is the future one. And if all of this fails, it's just going to throw errors that there is Auto-Arima train error, and this is Auto-Arima future error. So be careful when you're copying and pasting. As you can see, I do make these mistakes just because there's a lot of copying and pasting. Right, the next thing I'm going to do is to plot it. So again, this is a direct copy paste from the previous video, all the individual models. But what I have changed here is that for each of our forecasts, so training forecast 1, training forecast 2, future forecast 1, and future forecast 2, I have a try and except. And this is because some of the countries are going to throw you an error in some of these models. So let's say Auto-Arima is not going to work for Greece. It's going to throw you an error. If you don't put it into try and accept, then the whole code is going to fail. But this way, if it fails, it's just not going to plot one of the models. So this is why I have try and accept on every single plot of these 4 models. And as you can see, the output, if I run it again, it throws me an error country, and this is because I have run the whole code and rename country with a capital. So I'm going to have to go back at the beginning. Where is it? SQL query, this one, then we need to run this one, then we need to run this one, this one, this one. And then we should be good to go. If I come down again, run the code, we still get different results. I probably did something wrong. So okay, this is a mistake. Okay, so this should be 0, 2, 3, 4, 1, 1, 0, 2, 3, 4, 4. Okay, so 0, 2, 3. Apologize for the error. If we run this again, we should get exactly the same results as before. There we go, same as before. So moving forward now, we want to take all this code I've just explained, copy it and paste it down here below, and also add profit and regression on top of this model. So the output of all this code, it's going to look like something this graph below here, where we have all the validation models, so 4 models for validation and then 4 models for the future going forward. So what you need to do now is copy and paste the same code, and then the things I have added on this code is down here. I have also added a delete, a training forecast 3 and a training forecast, and a future forecast 3. I have also deleted the DF forecast 3, which I don't think we've created yet. I think it's in the next step. Arima is going to stay exactly the same. So this is exactly the same as before. Same thing with Auto-Arima, exactly the same as before. And now we need to add these lines of code in our loop. So this code is exactly the same code as the individual profit model we've run at the top. The only difference is that this time is going to take its value from these data frames we created here at the top. So if we just explain this now, first thing we do is that we create a copy of the train data, then we select 2 columns because we need 2 columns to pass into the model. The third thing we do is that we rename the columns because, as we've explained, profit only accepts these 2 column names, DS and Y, and then we pass the date into the datetime. We repeat the same process for all the data, not just the training data. Then we need to create 2 new indexes because if you remember, profit takes their index as a data frame versus the other models that take their index as a series. So what I do here is that I take my index for 7 years, the series one, and then I pass it in a data frame, I rename it, and then I convert it to datetime so I can use it to make predictions. And I do the same thing for our future index, which is after 2017. Then we define the model, we fit the model, and then we make our predictions. So this prediction is for the validation. So I pass the validation index. Then I pass the prediction back to PD series so I can visualize it. And the index here is going to be the series index, not the data frame. So the one we've created at the top. And then I rename it into profit, and then I repeat the same process for the validation phase, but this time I feed all the data and I use the future indexes. So what this is going to create now, if we scroll down at the end, is going to create this yellow line, which is the validation one with the circles. So this is a prediction for the validation, and this is a prediction for the future, which is the yellow straight line with the triangles. Right, the next thing we're going to add is going to be the regression. And I know we haven't explained the regression at the top individually, but I thought it's good to have, as regression is going to give us the slope, which is the direction of the trend, if it's positive or negative. And we can also calculate the year-over-year change based on the slope, which is the steepness of change. Right. To add regression now, the first thing you have to do is to create an ordinal month number. And this is because regression doesn't take a date as an input. It's not like forecasting models. Sorry, it's not like time series models. So if I show you what we do over here, if I run this train.head, actually I can run all of it. So we don't have the ordinal. Let me just run it again. If I run it again, there we go. As you can see, what this month number ordinal did is that it took this date and it converted it into a number. And because we are moving a year ahead every time, if you calculate the difference of this month number ordinal, if I just take it into Excel and I calculate the difference between these two, so I do this one minus this one, you can see all of them is 365 days difference. So all of them have 1 year difference, but the difference between these two columns now is that this one is a number and this one is date. And regression needs to take a number as an input. This is why we are creating this month number ordinal column. So we repeat the same column for all data. So we do the same for both train and all data. And then we need to do the same for our indexes, because again, we cannot fit a date and expect a prediction. We have to fit a number. This is why I'm also creating this forecast date ordinal column in our indexes. So if I run this, you're going to see that our index has the ordinal values too. So the next step now is to fit the linear regression. So first I call it and then I feed it. And when we feed it, we have to feed the ordinal number, which is the ordinal year number, dot values, and then dot reshape -1, and then here we need the train data values. Then we need to make a predictions, which is going to be our training forecast for, and into the regression dot predict, we need to feed the ordinal value from our index, the one we've just created over here. Then we need to pass it down back to series so we can visualize it, pass the same index as Arima, and then rename it to regression. So what this bit is going to do now, this training forecast for, is going to be this black regression line we see over here. And then if we repeat the same process for our future, we are going to get this black line over here, which is the future regression line. The next thing I did over here is that I have added all the mean square errors for all of our 4 forecasts. So this one is Arima, if you remember, this one is Auto-Arima, this one is Prophet, and this one is the regression which we have just explained. Something else we need to add now is that we also need to drop the training forecast for and the future forecast for from here at the top. So if we do this, and then if we run all this, everything is good to go now. Right, the next thing we have to do now is to copy and paste the code down here and somehow try to save our results. Because remember, this is a for loop that is going to go through every single country and create these 4 forecasts. But we haven't saved those anywhere yet. So we need to somehow, each time we have a loop, save the results so we have the final data set at the end. So what I did over here is, first of all, we need to copy the whole code from above, paste it down here. Everything is the same up until Prophet, regression, saving the mean square error, plotting, saving the results. So this is a new bit. So what I did here is that I have created, this is 1, 2, 3, and then 4 different data sets, data frames that have the summary of each model. So what I'm going to do is that I'm going to copy one of them and show you how I've done it below, and then you can copy the same code 1, 2, 3, 4 times and then adjust it depending on the model. So if I copy this and paste it down here so we can run it bit by bit. So the first thing I did is that I took our forecast, I dropped the index and renamed the columns. So this is going to create a data frame. So if I quickly copy this, if I paste it down here, and then if I run it, and then if I show it to you, so let me just copy this and paste it, you can see we have a data frame with the date and then the Arima forecast validation. So the next bit I do is that I repeat the same thing for the future. So let's just show the training now and then we can show the future. The next thing we do is that we are also adding 2 new columns. So let me just copy this and run them too, so you see what's going on. So the reason I'm adding these 2 new columns is because I'm about to union them. So here I'm going to have my forecast, my training forecast, and below I'm going to have my future forecast. So both of them have the same structure now, so we can actually move on and union them together, combine them together. However, before we do that, we need to reorder them so they go on the right place. So date is going to go under date, but this is the Arima forecast validation, but this is the future. So what I need to do now is to reorder one of them so I can union them with the right columns. So this is where this line of code comes into play, where is the reordering. So if I run this one too, and then if I run them again, you can see that both of them now have exactly the same order. So the second column is the future, and the third column is the validation. So the next step now is to concatenate them together. So it's going to be this code here. So if I run this code quickly so I can show you, you can see that the first 7 columns is the validation, and then the rest is the future. Then I add the country on the data set. Then I add the machine learning method, which is the Arima. And then I also add the mean square error. So if I copy this code and run it, so I can show you the final table, which is the DF1 forecast. If we run this, and then if we copy this, and then if we run this, you can see that we have the forecast for the future, the forecast for the validation, we have the country, we have the method, and we also have the mean square error. So when we change country, then here we're going to have a different country and then the numbers of the other country. Right, the next step now we have, which is the final step, this is why we have try and except. Assuming the forecast 1 fails, we still need to have a data frame that refers to Arima, just because later on I'm going to join all 4 DFs, all these 4 forecasts together. So if one of them is missing, then it's going to throw me an error at the end. So what I want to do is that if forecast 1 fails, so if we cannot run Arima on a specific country, then I still want to create this data frame with exactly the same column names. So if I copy this and paste it down here, but instead of having actual numbers in, it's going to have NAs. It's going to have NA for date. Then we are going to have Arima forecast future, which is the Arima forecast future. Then we are going to have the Arima forecast validation, which is this one. Then we're going to have the country, then we're going to have the machine learning method, and we are also missing Arima mean square error actually, so I need to add this in our code. So if I copy this quickly, actually this was going to be one of the errors which I was going to identify in later stages, which is the testing on more countries and fixing bugs, but we can just add it from this step over here. So if I copy this and I go back to the initial code for DF1, I am missing comma machine learning method, sorry, is the mean square error. So mean square error, and I want to set it to np.none. And I need to do the same process now for all 4 forecasts. So I have shown you how to create one of them. Then what you need to do is copy and paste it and recreate the same thing for this one, which is the Auto-Arima. Then you need to copy and paste it and replace the values for profit, which is forecast number 3. As you can see, I have mistakes over here. This one should be profit, and also I should have the profit mean square error, but it's things I'm going to fix later on in the next stage, which is fixing some of the bugs, because all these bugs, they do happen when you write big chunks of code. And then we have the regression one. So the only difference with the regression one is that we are actually adding the slope. So this is new. We are also adding the direction. So we have an if statement here that says, if the regression slope is less than 0, then I want to map it as a negative trend. Otherwise, it's a positive trend. And we also have the slope monthly change. It's not projection actually, but okay, I'm going to leave the name as it is. And what this does is that it takes the last value of our prediction minus the value before that. So that is going to be the difference between two data points. So it's going to be the difference between, if black is regression, it's going to be the difference between this number and this number over here, which is going to be our how did I name it? The slope monthly change. Right, before we get into the next stage, if you feel that you're getting enough value out of this video, I would really appreciate it if you click that like button, subscribe to my channel, and enable notifications for my future videos. Right, moving on, the next step we have is aggregating the data to avoid duplication. So the reason we are doing this, let me just copy this piece of code so I'll show you what it does. If we come down here and we see our final df1, as you can see it, we have a duplication on 2017 because both the validation forecast and the future forecast have a date for 2017. So we want to sum the data in order to avoid this and have only one line for 2017. So in order to do this, we need to aggregate the data. So I say df.1.group by, I want to keep date, country, and method as they are. So this is going to be the date, the country, and then the method. And then I want to aggregate the rest. Because the rest are values, we can aggregate them. So for the Arima forecast future, I do a sum. So for this one, is going to sum everything together. So because this is 0 and this is a number, it's going to use only one line. Then I want to sum the validation. And then for the mean square error, I want to take the max. I don't want to sum these two together. I just want to max it. So if I run this, and then if we view our final forecast, you can see that for 2017 now, we only have one line. We don't have two lines as we had over here. And now we can perform our joins without having any duplicated values. So if I scroll up here, you need to repeat the same process for all DFs. So we have 4 DFs. And as you can see, all of them are going to follow the same code. The only difference now is that in our regression forecast, we have a few more columns which we need to add. We need to add the regression trend direction here. And then in the aggregations, we also need to aggregate the slope. So we want to take the max. And we also want to aggregate the slope monthly change. And again, we want to take the max. We don't want to sum these two because then we're going to have the wrong numbers. The next step now is to join all these 4 data frames together. So this is where the left join comes into play. So this line of code joins df1 with df2 and saves it into all forecasts. Then I left join in all forecasts df3, and then I left join in all forecasts df4. And just to show you how this left join works, I'm just going to copy this quickly and then paste it down here. This one is our df1. This one is going to be our df2. As you can see, they both have the same structure. So what I do in the join is that I take all of df1. So it's going to take all of this df. And then from df2 is going to take the date, the Auto-Arima future forecast, which is this one. Then the Auto-Arima forecast validation, which is this one. And the mean square error, which is this one. So we are excluding the method and the country. And then we are doing a left join, how equals left. And then we want to join on date. So it's going to match this date with this date over here. So if I run the join, just to show you how the final output is going to be, We still have 12 rows, so we haven't changed any of the rows. But the difference now is that the data frame doesn't stop in Arima mean square error. We also have the Auto-Arima future, Auto-Arima validation, and Auto-Arima mean square error. So left join is literally taking columns from a second data set and then joining them on the first data set. So same thing as this one, but we have another column, and another column next to it. Right. So I need to repeat this process 3 times as I've done above here, because the first one is for df1 and df2. The second one is for joining df3 on top of all forecasts. And then the fourth one is joining the 4 forecasts on top of all forecasts. So as you can see, for the regression, we also need to take the slope and the monthly change and the trend direction, still a left join, still joining on date. So our final all forecasts is going to look something like this. If we run it, you can see up until here is Arima, then is Auto-Arima, then is Prophet, and at the end is regression. And then the final step in this code is done so each time we have a new country, is going to take this all forecast and is going to pass it on another data frame, which is called final forecast. So the way this code is going to work now, let's say in all forecasts we have Australia data, it's going to try to run this line of code first. But when it comes to pd.concat final forecast, because this is not defined yet, the first time we run it, this line of code is going to fail. So it's going to move into except. So it's going to pass into final forecast all forecasts. So now final forecast has Australia data in it. But in the next country where we're going to have Greece, for example, is going to try and run the first bit, and it's going to try to concat the final forecast, which now exists, which is Australia, with the old forecast, which is going to be the new data, the new country, which is going to be Greece. So this line of code is going to work every other time except the first time we run this code. So with this way, we can pass multiple different forecasts for different countries into one data frame, which is going to be called final forecasts. Right, moving on, we need to test this model now, this code we have, on more countries and see if it works or if we get any errors. So what you have to do is copy all this code and then paste it down here below. So I haven't changed anything on this code. The only difference now, in countries, I have added 2 more countries, and then click run and see if it works on more countries. So if we scroll down here, exactly the same code, I haven't changed anything. We can see that it works fine, should work fine on these countries. There you go, you can see Australia, Cyprus, and Greece, and we can see that the models did not do very well to predict the validation, and also the same with Greece. One of the models got it completely wrong, it went all the way down versus the actuals, which is more of a plateau. Right, so the next step now is to try and run it on all the countries and see if there are more errors or bugs we need to fix. But because this takes a bit more time, since we have almost 200 countries, I have identified that Denmark gives you an error. So if we run this and try to fix the error that we have, if we scroll all the way down and we read the error, straight away we can see the error comes from the mean square error code. So this line over here, so we can copy it and paste it down here to investigate it more. And also it says that input contain NAs. So we only have 2 inputs here. This is the first one and this is the second one. And if we check the second one, which is the one we're actually changing, so if we comment this out and run it, you can see that the first forecast model, the training forecast 1, which is the Arima, is failing for Denmark. So what we have to do now to avoid getting errors so we can let the code run on all countries, I actually have the fix down below in this code where we fix all the errors. The fix is that we need to do the try and except on all the mean square errors. So you can see it now, try and accept. If it fails, then we need to pass a value of 0 because we still want to have the mean square error for all models. And then we repeat the same process for forecast 2, forecast 3, and forecast 4. So this is one of the changes. And then the other change we need to do is down here. As I was saying before, we forgot to add the Arima MSC at the data frame, on this data frame, in case it fails. So the last fix I have found is to add the Arima mean square error and pass it as NA. Same thing with this one down here, the Auto-Arima, we need to pass the mean square error as NA. Same thing with the Prophet, we need to pass the Prophet mean square error. And then for regression, I think we got it right the first place. So this is the final piece of code now with all the error fixing. And if we try and run this now, so to run this, actually, you're gonna have to copy the code from above, paste it down below, and then leave countries as all countries. Do not specify a different country. And this is gonna start going through every single country and running the code. As you can see, Australia, then we have Austria, Belgium, Canada, and it's going to run for all countries. And when this finishes, you'll be able to see all the countries and the visualizations with all the models and their predictions, as you can see over here. Right, the next step now is to combine our predictions, so our final data set that has all the forecasts for all the countries, with the original data set that has the actuals. So just to show you what we're trying to union or join, this is the original one, the forecast data set that has the countries, the time, and the actuals, the values. And then our final forecast data frame, which is this one, that has all the forecasts for all the countries and the dates going forward. So in order to join these two together, we're going to have to make them have a similar form, actually a same form. So what I do down here is that on the original data set, which is the forecast data, I'm creating new columns and I'm setting them as none, NA. And the new columns are all the new columns that we have in our final forecast. So here we create all the new columns. At the end, I'm also renaming time to be date. So I'm renaming this time to be to date. And I'm renaming the country with country as capitals. And then from the final forecast, which is this one, I delete the machine learning method because we are not going to need it. And I also add the value to none. And this value I'm adding into this one is actually the value from this one. So I'm making sure both data sets have exactly the same columns and column names. So if I run this quickly now and I show you again the same two data sets, so this is the one, you can see we have added all these new columns, and this is the second one. So the only difference from the second one is going to be missing the machine learning method. The next step now is to reorder them so they have the same order, because right now they don't have the same order. You can see this one starts with country, this one starts with date. So we need to reorder them. So this is what I do over here in order to concatenate them. So if I run this piece of code now, we have a concatenation. So this concatenation is actually a union after the reordering. And if we view our union, we can see dot head is going to have the actuals and all the NAs. And if we check the tail, at the end, we're going to have all the forecasts. The next piece of code I have now is that I want to set everything that has a value less than 1. So I want to set all these zeros into NAs. And the reason I need this is that later on when we take it into Power BI, if they have 0, then you're going to see a line going down and then zeros in the previous years. But we don't want to have zeros, we want to have NAs, because NA does not appear in the graphs, in the visuals. So very simple, for all of our values in our final data frame, I just set them into NA if their value is less than 1. And the last bit we have is the exporting. So the first piece of code is going to export it in an SQL server. You can ignore this one. Or if you want to learn more about this one, I'm going to have a link in the video description that I explain how to connect SQL with Python. And the final bit we have is exporting our output into a CSV file. And if you want to get the location, you run this os.get current working directory, and you are going to get the location where the output of the CSV file is going to be stored. Right, data friends, this is it for this video. In the next video, I'm going to show you how to take this output we have just created with the forecasts and the predictions and create this Power BI dashboard from scratch. This Power BI dashboard is actually interactive, so you can click in any country you want and you're going to see the results or the forecasts of our models. Additionally, you will be able to see the mean square error of the models. So you can choose the one that has the least mean square error and then get the right predictions for the future, 2023, for example, etc., etc. Right, I hope you enjoyed this tutorial and you've gained enough value out of this tutorial. If you feel like you did, please click that like button, subscribe to my channel and enable notifications for my future videos. If you have any questions, please let me know in the comments below. Otherwise, thank you very much for watching this video and I'm going to see you in the next video.